Hello friends, how are you? I hope all of you are fine and safe. So, I am here with a new chapter, that is solution, from your chemistry syllabus. And today's topic is vapor pressure. So, let's start. And before starting vapor pressure, we have to know about solubility and Henry's law. So, what is solubility? So, here we are going to discuss about solubility. First, we will take a solute that we can say A and a solvent that we can say B. So there are some types of solutes which will easily dissolve in solvent, and some types of solutes are there which will not easily dissolve in solvent, and some solutes are totally insoluble in solvent. So here we take the solute A which will easily dissolve in solvent B. So first we will add small amount of solute A in solvent B. After that, we will keep adding the solute A into the solvent B. We are keep adding this solute till that time. After that, the solute A will not going to dissolve in solvent B. That means we will add maximum amount of solute A in solvent B. So for example, if we take two solute, one is NaCl and another is AgCl, and we will dissolve it in water. So NaCl, this is easily soluble in water. So if we add 400 gram of NaCl into water, it will be easily dissolved in water. But for AgCl, if we add greater than 1.9 gram of AgCl into water, it will not going to dissolve. That means it will make a insoluble solution. That means AgCl make a precipitate with water. So there are two types of solutes. One is easily soluble in water, that means this much amount easily soluble in water. But here it is very small amount of solute which can easily dissolve. But greater than this, then it will not going to dissolve. So if we take another example like NaCl, sugar, for solvent it is water, and here anthracene, and here we will take benzene. So what will happen? NaCl and sugar, it will be easily dissolved in water. We have already know about this. It will be easily dissolved. But anthracene, it is insoluble in water. It will not going to dissolve. It is insoluble. Totally insoluble. But anthracene, in benzene, it is easily soluble. In benzene, anthracene will be easily soluble. Why? Why this will happen? Because in sugar, if we take sugar solution, in sugar there is a polar bond. This is a polar compound. And water, this is also polar compound. So polar dissolve in polar. And anthracene, this is non-polar. And benzene, this is also non-polar. So polar, that will dissolve in non-polar solvent. So here we can say one thing, that is like, dissolve, like. means polar, dissolve, polar solvent, and for non-polar, dissolve in non-polar solvent. So if we take another reaction, that is solute plus solvent, that will make solution. So this solute plus solvent to solution, this reaction is called dissolution. Basically this is the forward reaction. But when this reaction will be backward, that means solution will be make the solute and solvent, that will cause precipitation. So here we can say at any point where no more dissolution will occur, basically that is called saturation point. Saturation point means at this point the maximum amount of solute will dissolve in solvent. So at this level maximum amount of solute is dissolved in solvent, and that is called saturated solution. And below this saturation point, that solution will be called unsaturated solution. And above this saturation point, that solution will be called supersaturated solution. So here we can see one thing. Here if dissolution will occur, that will make the solution, and precipitation will occur, that will make the solute, and you can say precipitate. So now we can say one thing. If the reaction is going backward, in that time del H, or what is del H? That is enthalpy of the reaction, that will be less than 0 when the reaction is backward, and this is called exothermic reaction. And when the reaction is forward, at that time enthalpy will greater than 0, that will call forward reaction, and it is endothermic reaction. According to Law-Chatelier principle, this enthalpy will change according to forward reaction and backward reaction. This is very important. About the effect of temperature and pressure. So first, how the temperature will depends on this type of reaction. So as we increase the temperature, the reaction will go backward. But as we decrease the temperature, the reaction will go forward. And if we consider about pressure, so what will happen? So we can say this is a container, there is solvent and there is vapor. Pressure increased. If we increase the pressure, what will happen? increase the pressure, what will happen? The stress, the pressure will increase with this solute and solvent part. And in this portion, number of molecules will increase. So here you can say the number of molecules will be less and the volume will be greater. But here number of molecules will increase and volume will be less. So as the pressure will increase, the volume will decrease, and volume will decrease, the number of molecules will be greater here. So from this effect of pressure, we can formulate a formula. Basically, scientist Henry give a mathematical expression according to this pressure effect on solute and solvent. So what is that Henry laws and Henry formula? The law is that P equal to KH into X. Here P is pressure and X, that is mole fraction of the solution. So as the pressure increase, mole fraction will increase. So here we can see this, as the pressure will increase, the volume will less and number of molecules or mole fraction will increase. So this is the basic formula of Henry's law. Here P is pressure, KH, that is Henry's constant, and X, that is mole fraction of solution. So from this law we can conclude, as the pressure will increase, the mole fraction will also be increased because they are directly proportional, and as the pressure will decrease, the mole fraction will decrease. So this is the effect of pressure and temperature. What is vapor pressure? To introduce vapor pressure, first I will take some liquid. That liquid A. Now here I will take a closed container like this. Here I will keep liquid A like this. So here what will happen? At any temperature, this liquid molecule will accept from this solution, and this liquid molecule changes into gaseous molecule here, and this gaseous molecule occupy this empty space of this closed container. So what happened basically? If this liquid is volatile, then this gaseous molecule will be in large amount, and this gaseous molecule now giving a pressure to the wall of this container. Basically, this pressure of this gaseous molecule will call vapor pressure, because this is the vapor of this solution and this will give the pressure to the container walls. So that this is called vapor pressure. So we can say vapor pressure, that is PA naught. So here if we take another liquid like B, again in an closed container, then what will happen? Again this liquid solution molecules will escape from this liquid and go to this empty space again and give a pressure to the wall of this container. This is also called vapor pressure. and we can say this is PB naught. So we get 2 vapor pressure. From liquid A, vapor pressure is P naught A. From liquid B, we will get the vapor pressure, that is P naught B. Now we can say the total pressure. That is PT equal to P naught A plus P naught B. But how this P naught A and P naught B will come? So here again we can draw a container like this, and here we can say vapor, that is A and from A and B, and liquid, that is also from A and B. So here another thing we can say, mole fraction of A plus mole fraction of B, that is also total mole fraction of this liquid and vapor. So again we can write another formula, that is from Henry's law, PA proportional to XA and PB proportional to XB. This is from Henry's law. We have already know this formula. So now if we take XA equal to 1 and XB equal to 1, then what will happen? PA equal to P naught A and PB equal to P naught B. So here we can draw a diagram. Now here we will take the vapor pressure, and this will be mole fraction X. So now we can write this is XA equal to 0 at this point and XA equal to 1 at this point. So again we can write XB equal to 1 at this point and XB equal to 0 at this point. So if we take this position, that is vapor pressure P naught B. So from this point what will happen? Pressure go increase and come to this point. And again if we take this point as P naught A, then vapor pressure will again decrease and go to this point. So here what we can say, P total equal to P naught A XA plus P naught B XB. So here we can again write P naught A XA plus P naught B XB. We can write 1 minus XA, because XA and XB totally 1. That's why we can write 1 minus XA. Again we can here write P naught B plus P naught A minus P naught B into XA. So this is the formula of total vapor pressure. So again in the diagram we can draw this from P naught A to P naught B. This is the P total, that is P naught B, P naught A minus P naught B into XA, and this is the PB and this is PA. So this is the diagram for vapor pressure, and this is the formula of total vapor pressure. Here XA, this is the mole fraction of liquid A. P naught A, this is the vapor pressure of A liquid in pure form. P naught B, B liquid in pure form vapor pressure, and this is also vapor pressure of B, and this is total vapor pressure. So now let's do the examples. So here we will take two substances. One is CH-Cl3 and other is CH2Cl2. So we can take its A, this is as B. So what is the vapor pressure? Vapor pressure of P0A, that is 200 millimeter Hg, and vapor pressure of B, this is 415 millimeter Hg. Again, if we are taking the amount like 25.5 gram and this amount is 40 gram. And another thing that we can take, this is molecular weight 119.5 and this is 85 gram per mole. Now what we have to do here? We have to count the total pressure PT, that we have to count here. So first what we will do? First we will write the equations. That is, first we have to count PA, that is equal to XA P0 A, and we have to count PB XB P0 B. So here what is XA and XB? The formula of XA, that is NA by NA plus NB, and XB, that is NA by NA plus NB. Sorry, this is NB by NA plus NB. And one thing we can write 1 minus XA. So now what is NA and NB? So from this we can write NA equal to 0.2 and NB equal to 0.470. This is the number of mole we are counting. So this is NA and this is NB. So if we put this number 0.2 plus 0.470, then what we will get, if we calculate it, then we will get this is 0.312. And if we put 1 minus 0.312, then what will come? 0.688. So this is XA and this is XB we have get. Now we will count pressure PA. We already know XA, this is 0.312 into we have P0 A, this is 200. Then what we will get? 62.4 mmHg. This is the one pressure formula, and from this what we will get? 0.688 into 415, that is equal to 285.5. If we calculate it, we get this is PB. Now we have to calculate the total pressure. This is PT into PA plus PB equal to 62.4 plus 285.5 millimeter Hg, that is equal to 347.9 millimeter Hg. So this is our answer. So this is very easy. I think you can clearly understand these numericals. So we can do another one numericals. Okay. So another example that we can do. So here we have the another total vapor pressure, that is 600 mmHg. Again, vapor pressure of A, P0 A, that is for liquid A, for pure liquid mmHg, and for pure liquid B, that is 700 mm Hg. So now what we have to calculate here? We have to calculate the mole fraction of air. So how can we calculate this? So here we can take, for liquid A, mole fraction is A, and for liquid B, mole fraction is Xb, that is 1 minus Xa. So here we can write PA equal to XA into P0 A, that is 450 XA. We can write this. Another thing, we can write PB equal to XB P0 B. So here again we can write 700 into 1 minus XA. So now we already know PA, PB. Now again we know this to P total. So what will happen? Here we can write PT, that is equal to 600 millimeter Hg, equal to PA plus PB. So if we write PA plus PB, we can write this 450 XA plus 700 1 minus XA. So from this 450 XA plus 700 minus 700 XA. So here we can write 700 minus 250 XA. So 600 minus 700 equal to minus 250 XA. From here we can write XA equal to 100 by 250, and that is 0.4. So this is the mole fraction of A. This is our answer. So this is also very easy. We are just keep the value in the formula and we are getting the answer. This is very easy, I think. So Vapour pressure, this is all about Vapour pressure of liquid solution basically. Here A and B that we will take, that is liquid and liquid. So this is basically liquid solution. So again we are taking a mixture of solid and liquid. We know solid mixture, if we take the solid, that is not volatile. But if we take liquid, that may be volatile. So what will happen here if we mix some solid and liquid in a closed container? So this is the liquid A and we are putting the solute or solid here in the surface. So some solutes or solids are insoluble in this liquid and some are soluble in this liquid. So some parts will remain in the surface of this liquid portion. So what will happen here? If some solute will dissolve in this liquid, the concentration of this solution will increase. But evaporation rate, that will decrease because this surface is already obtained by this solid molecule. That's why liquid molecule cannot escape from this solution in this empty space and cannot make the gaseous molecule that much. So that this evaporation will decrease but concentration of this solution will basically increase. So for solid molecule, we can easily say the formula is same here. vapor pressure of A, that is equal to mole fraction of A into vapor pressure of A, and vapor pressure of B, that is equal to XB P naught B. So formula is same here, but the evaporation rate, the gaseous molecule, that will decrease here. So from this we can write the Raoult's law. Basically this formula is called Raoult's law. Vapor pressure of a solution A, that is equal to mole fraction into pure liquid vapor pressure. So this is the Raoult's law. So I think all of you have understand this topic. Let me know, and please like, subscribe and share our channel NewtonGATE Academy. And for more details, please visit our website www.newtongateacademy.com or www.newtongate.in, or call us on this number. And if you find any difficulty to understand this, so please comment and let me know your doubt. Thank you.